Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now going to answer question number 7 from the specimen paper for the Pure Mathematics P3 Cambridge exam from 9709 syllabus. And here we have a question which is to do with trig identities. Part A and part B is about trig equations. And here we're going to be dealing with the type of questions which I normally call R alpha questions, right? And you'll understand why in a little bit. Okay, now it says, by first expanding cosine x plus 45 degrees, express cosine x plus 45 degrees minus root 2 sine x in the form r cosine x plus alpha, where r is greater than 0 and alpha is between 0 and 90 degrees, giving your answer, or give the value of r correct to 4 significant figures and the value of alpha to 2 decimal places. So we have to keep those in mind. The instructions about rounding in case we forget. Now, expanding cosine of x plus 45 degrees. Now, this is something which a lot of students in the beginning, when they first start this particular topic, they do some very strange things because maybe their lack of understanding. Now, a lot of people will do something like this, and this is actually not correct. They will write cosine x plus cosine 45, and this is completely wrong. This is incorrect. This is not the correct way of expanding something like this. It's not like, for example, if you have a times b plus c, where you can do, okay, a times b plus a times c, where you multiply a by b and a by c. A by itself is something that's complete by itself. B is something complete by itself, and so is c. Now, when you say cosine or sine or tan, okay, there has to be an angle with it. Cosine by itself doesn't mean anything. I can't say cosine times x is cosine x. No, cosine of an angle. The angle in this case is the whole of this x plus 45. This is the angle associated with the cosine function. Okay, so it's very important for us to understand that this is something complete in itself. It's not like cosine is different, from x and 45. X plus 45 is the angle that we're considering the cosine ratio of. So this is not the way to expand such an expression. All right, it's not like this. So don't treat it the same. All right, there's in fact some proof for the expansion of the sine of, this is called like a composite angle, the sine of a plus b. There's a proof to show the expansion of this, which we don't need to go into, but in your formula sheet we have those, written out. Okay, we know that. So, once you've proved the sine of a plus b, from that you can prove the sine of a minus b. You can also prove the cosine of a plus b and the cosine of a minus b, and also the tan of the same thing. Right? All of those can be derived once you have worked out what this is. Okay. Now, we don't need to go through those proofs. Okay. There's no need for us to go, especially in this particular question. We don't need to go through the proofs. We have to just go to the formula sheet, which I've got a copy of here, and we have to look for the correct form that we're looking for. And we can see the correct form we're looking for is cosine a plus b, which is this, and we can see how it expands. This is how you would expand it. So the cosine of x plus 45 is going to be identical to and you're going to have cosine. Now here you have cosine a plus b equals cosine a cosine b minus sine a sine b. So in this case, our a is the x and our b is the 45. So you have cosine a, so it's cosine x times cosine b, which is cosine 45. And if there's a plus here, there's a minus there. So minus, and the sine of x times the sine of 45 degrees. All right, so that's how this expands. Okay, the proofs for it were not given. We didn't go through it, but what you need to do in your exam is go to the formula sheet, and everything you need is here, and you can find it there. Okay, in fact, they give a lot of formulae for trig that at Excel, which you know, in that you're basically, all of these identities are not given. This is not given. These are given. This is given, but the double angle formula are not given either. None of those are given in the formula sheet for at Excel. So you have a bit of an advantage there in the Cambridge. Anyway, so there we have the way to expand this. So we can now write this in more exact form, because we know that the cosine of 45 degrees is root 2 over 2. 1 over root 2 or root 2 over 2. Okay, you can use a calculator if you're not sure. Okay, but I know cosine of 45 and the sine of 45 is root 2 over 2, so we can prove that here. Cosine 45, root 2 over 2, and also the sine of 45 is also root 2 over 2. Okay, so this is going to be root 2 over 2 times the cosine of x minus the root 2 over 2 times the sine of x. Okay, so that's what this expands to give us. And then it says, so we first did this, so we've written this out now in this form. It says express cosine x plus 45 minus root 2 sine x in this form. So we got cosine of x plus 45 minus root 2 times sine of x. Now we can say that this is equal to this plus this minus root 2 sine x. So you have root 2 over 2 cosine x minus root 2 over 2 sine x minus root 2 sine x. We can simplify this. These are like terms. We have minus root 2 over 2 minus root 2. That's going to be minus 3 root 2 over 2. It's like you can say this is like minus x over 2 minus x is minus 3x over 2. So this is going to give you root 2 over 2 cosine x minus 3 root 2 over 2 sine x. Okay, so that's what this is going to give you. And now we can say, or we can now rewrite this in the form they want, which is r cosine x plus alpha. Okay, so what we can say here is we can rewrite this in that form. So I'm going to take this as root 2 over 2 times cosine x minus 3 root 2 over 2 sine x is identical to, and we want r cosine x plus alpha, so r times cosine x plus alpha. Now we can expand this again using the same formula, which I got rid of. I think I cancelled it, no problem. We know the formula is in this form here, that you're going to have cosine of x times cosine of alpha minus sine of x sine of alpha, using that same expansion. So when you expand that, you'll also have r multiplying both of the terms. So you'll have r times the cosine of x times the cosine of alpha minus r times the sine of x times the sine of alpha. Okay, so that's how that will expand. And we can now, what we can do here is we can do what's called comparing coefficients, because this is an identity. These two sides of the identity are identical. Okay, so what I can do here is I can say, let me, for example, take the coefficient of sine x. Let me look at the coefficient of sine x on this side and that side. That's sine x there. Okay, let me just okay, so here's sine x on this side, here's sine x on that side. Now we can see that the coefficient of sine x, okay, on this side is minus root 3 over 2, root 3 minus root 3 minus 3 root 2 over 2. On this side it's minus r sine alpha. So we can say 3 root 2 over 2 is equal to r sine alpha. Okay, because these are identical. So the coefficient of sine x on one side must be the same as the coefficient of sine x on the other side. They must be the same thing, because these two must be identical. So however, the number that's the coefficient of sine x here and the number that's the coefficient of sine x there must be the same. So we can say 3 times root 2 over 2, okay, is equal to r sine alpha. They must be the same. Okay, that's one equation. That's by comparing the coefficients of sine x. We can do the same thing also by comparing the coefficient of cosine x. If we look at cosine x on this side, we have on this side the cosine x, we have root 2 over 2. On this side, we have r times, well, sorry, let me do it the other way around. The coefficient of cosine x here, and the coefficient of cosine x there. We can see here that on this side you have root 2 over 2, and that's equal to r cosine alpha. Okay, once we've figured that out, we can now work out what the value of r and the value of alpha is. And there's a couple of different ways we could do this. One of the ways is, but I'll show you both ways. The way that I normally prefer is to make a right angle triangle. Okay, and just a little sketch, you don't have to do it accurately. So we have a right angle triangle, and we call one of the angles alpha, so let's say this is alpha. And then from here we can say, if we take this statement here, we can say the sine of alpha is equal to, now what I'm going to do, I'm write it as like a whole fraction, like 3 root 2 over 2 divided by r. I'm just rearranging this. Sine alpha is 3 root 2 over 2 divided by r. I'm taking this as one whole numerator just to make life easier for us. You'll understand why hopefully later. So 3 root 2 over 2 is the opposite, and r is the hypotenuse. And similarly for cosine alpha, we can say it's going to be root 2 over 2 over r. Alright, so if you rearrange this, you have root 2 over 2 all over r. You can write that as separate fractions for now. So that means if that's alpha, cosine alpha is adjacent over hypotenuse, so the adjacent side should be root 2 over 2. Now we can find the value of r by Pythagoras. We can say r is equal to the square root of, and we have to square these and add them together. So you have 3 root 2 over 2 squared plus root 2 over 2 squared. So r is going to be the square root of, this will be 9 times 4 over 2, which is 9 over 2. Right, 9 times 4 over 2, which is 9 over 2. Okay, no, sorry, 9 times 2 over 4. 9 times 2 over 4, which is 9 over 2, plus, and this is going to be 2 over 4, which is a half. So you have 9 over 2 plus 1 over 2, which is 10 over 2, which is 5, so you end up with the square root of 5. So we know r equals the square root of 5. I'll round it correctly at the end, just find what r is. And for alpha, we can use the fact that we know that the tan of alpha is opposite over hypotenuse. We can say the tan of alpha is the opposite, which is 3 root 2 over 2 divided by, I'll write it as a division because we've got fractions here, root 2 over 2. So we can say therefore that the tan of alpha is equal to 3 root 2 over 2 times 2 over root 2. Root 2's cancel out, 2's cancel out, so alpha is going to be inverse tan of 3. Alright, so we can work out what that is. We can say inverse tan of 3, we want it in degrees, that's 71.565. 71.565 degrees. We'll round it to the proper at the end. So now we know what r is. So we worked out what r is, we worked out what alpha is, we can write our answer down. Okay, before I do that, I'll just show you the alternative method. Other people would prefer to use a slightly different method. So this is like method 1 using the triangles. And method 2 is by basically squaring basically both of these equations. So you square this equation, so you end up with 3 times 2 over 2. Sorry, you square this, you end up with, let me just do it like step by step. So you have 3 root 2 over 2 squared equals r sine alpha all squared. Okay, and you also have for the second equation root 2 over 2 squared equals r cosine alpha squared. So you square each of these equations. So this gives you 9 times 2 over 4, which is going to be 9 over 2. So this is 9 over 2 equals r squared sine squared alpha. And this gives you root 2 squared, which is 2 over 4, which is a half, equals r squared cosine squared alpha. And then, so we have this like as equation 1 and equation 2. If we add the two equations together, okay, if we add the two equations together, equation 1 plus equation 2, alright, then you end up with 10, add these together, equals r squared sine squared alpha plus r squared cosine squared alpha, and this gives you r squared times sine squared alpha plus cosine squared alpha equals 5, not 10. That's a 5 there, because you have 9 plus 1, which is 10 over 2, which is 5. Okay, so we know that sine squared alpha plus cosine squared alpha equals 1, and it's even in the formula sheet for you guys. So it's pretty easy. We know the sine squared of an angle plus the cosine squared of the same angle equals 1. So we end up with 5 equals r squared. So therefore r equals the square root of 5, as we found earlier. Okay, and also for the tangent, we can just use these two together. Let me call this equation 3 and 4, just to make it clear. This is 3 and 4. Okay, this is what we get by squaring 1. And let's call this equation 1 and 2. For tan of alpha, we can just divide these two equations. If we do equation 1 divided by equation 2, you'll get tan alpha equals, you'll end up with this. If I do 1 divided by 2, I'm going to get exactly this. I won't rewrite it again, because we know that when you divide sine alpha by cosine alpha, you get tan alpha. The r's will cancel out. You'll have 3 root 2 over 2 divided by root 2 over 2. It will be exactly the same as what we got there. Okay, so those are two alternative ways of calculating the value of r and the value of alpha in such a type of question. All right, so now we can say that therefore we can write the answer that what they ask us to find, which was cosine x plus 45. So we can say the cosine of x plus 45 minus root 2 sine x is identical to root 5. Okay, was it minus that? Yeah, root 5 is equal to root 5. Now, they told us to round to 4 significant figures. So the root 5 will become, so the square root of 5. Okay, so I'll just write this here. That's equals 2.23606. 2.236067. So to 4 significant figures, it's 1, 2, 3, 4. So we stop at 2.236 times the cosine of x plus alpha, which they want that to 2 decimal places. Just make sure. Yeah, 4 significant figures and 2 decimal places. So 2 decimal places will be 71.57. 71.57 degrees. So there is the answer to our question. Okay, we've shown that, and you know that's the answer to that part of the question. Now I'm going to copy this and we'll use it probably in the next part of the question. Okay, so if we go to the next part of the question, I'll just paste this up here somewhere. Okay, let me just put it together. Okay, so there is the result from the last part of the question, which we probably use now. Remember, this was root 5 in its exact form. This is root 5, and this was the inverse tan of 3. Okay, in the exact form. All right, so now it says, hence solve the equation cosine x plus 45 minus root 2 sine x equals 2. So we should notice, first it says hence means we got to use part A. Secondly, we notice that this is the same as this. All right, so for us to solve the equation when it's written in this form, it's going to be very difficult. But if we have it written in this form, it makes life easy. So I can replace all of this with what it's equal to. So I'm going to write this as root 5 to give me a more exact form of answers in the end. So I have root 5 times the cosine of x plus 71.57. I can leave that for that like this for now, no problem. And that's equal to 2. So I need to solve this equation. Okay, and it's become, from something that looks complicated like this, it becomes something quite simple. So now we can basically try to solve this. First thing we're going to do is we're going to divide by root 5. So we have the cosine of x plus 71.57 degrees is equal to 2 over root 5. So that's the first step. So we can say we want to find the inverse cosine of this angle to find the angles within our range. Now our range are the angles between 0 up to 360 degrees. Now our range here has to be modified according to this. Whatever's here, you have to replicate that in this part here. So we have to modify the range so we don't get additional answers that are not in our range, and we don't miss out on answers which are in the range. So we always do this. So whatever it says here, this has to replace it. So the x becomes 71.57. X becomes x plus 71.57. Now, what do you do to the x to make this happen? Well, you have to add 71.57. So here you have to add 71.57 to 0. So you have 71.57. And here you have to add 71.57 to 360. Okay, so that's going to be, I think, 341.57. 331.5. So let's just make sure. 360 plus 71.57, which gives you 431.57. 431.57 degrees. So now that means the range of the angles that I need to find when I find the inverse cosine of this ratio, they have to be between these values. If they're outside of these values, they will in the end give us solutions which are not in our original range. Okay, so when I want to find the first angle, I have to press inverse cosine of this ratio, making sure my calculator is in degree mode, which it is. So I'll say inverse cosine of 2 divided by root 5. I'll use the exact value of root 5. That's better. Now that gives me, the first angle it gives me is 26.565. Okay, so 26.565. That's the angle that we get first. So x plus 71.57 is 26.565. Now what we'll notice about this is that this angle is not in our range. This is not one of our solutions. However, we don't just throw it away. Okay, we find other solutions in our range. Now we're dealing with the cosine curve. All right, so I'm going to go through 2 different ways of showing how to find the other angles. Now a lot of you will have used the cast diagrams. I'll do that first, and then I'll show you by the curves. I like to use the curves, to be honest, myself. But the cast diagram, I like to call it ASTC. I don't like cast. Why? Because cast, it's like you got to start from down here. Normally, it's best to start from the first quadrant. So I say ASTC. Okay, those in Saudi Arabia will understand amazing or awful, depending how your internet connection is. STC, Saudi Telecoms Company. Anyway, so ASTC, starting from the first quadrant, or cast if you want, no problem. All right, so the angle that we got was 26.565, which is somewhere in this, of course, in the first quadrant. All right, now we see that, so this is 26.565. Now we know that the cosine ratio was positive, all right, as we can see, and these letters tell us that the cosine is positive in this and this quadrant. So we need to find also the angle here. Now we're not going in the negative direction because we have got to start from 71.57. You're not going in the negative direction. We have to go in the positive direction. So we've got to find out what angle is over here. We've got to find what the angle is over there. That's the other angle, or one of the other angles that in our range. So we can see that this is like the whole revolution, which is 360. Remember, this is 360. This is 90. This is 180 degrees. This is 270 in terms of pi over 2, 3 pi over 2, and 2 pi. But we can see that this angle that we're looking for here is like the whole thing minus this little bit. Now this little bit is the same value as that. This is 26.565. So the angle we're looking for is 360 minus 26.5. So you have 360 minus 26.565. This is the other angle, or one of the other angles within our range. So we take this answer and we do 360, take away that answer. And that gives us 333.435. 333.435. 333.435. So 333.435. That's the other angle within our range. Okay. Now, is there another angle in our range? Well, if we can go all the way up to, as we stated here, 431.57. So if we go all the way around, let me just do this in a different color slightly. So if we go all the way around, one whole revolution, and then there's a little bit more, we'll see. That's going to be basically 360 plus. That's going to be 360. Let me just change the color. 360 plus 26.565. Okay, it's 26.5 more than 360. Is that in our range? So we're going to do this. Let's get the other. Okay, so that's the answer. So 360 plus that answer. That gives us 386.565. So we have 386.565. Is that in our range? Yes, it is. Okay, so these two angles are in our range. Okay, now are there other angles in our range? Well, the other angles will be basically 360 more than this, which is out of the range, and 360 more than this, which of course is outside of the range. So these are the only two angles in our range. Okay, so now we can go on to find what x is. Right, there's also alternative way of doing this. Okay, and that is by using the cosine curve. Okay, so if you think about the cosine curve, it looks something like this. And this is like 90, this is like 180, this is like 270, and this is like 360 degrees up here. Okay, so that's like 360 degrees. Now, what we can say here is what we found was an angle first over here, which is 26.565. All right, 26.68. Now, there's another angle which shares the same cosine ratio as this all the way over here, which is this angle over here. Okay, and what we can say basically is that because of the symmetry, this distance is the same as that distance. So this angle here is going to be 360 minus 26.6, 26.565, which is what we get from here. So with the cosine curve, it's always the angle that the calculator gives you, which was this, which is outside of the range, so we're not going to include it in the end. Okay, and then 360 minus the angle, always 360 minus the angle for cosine. So whatever angle this gives you, you just do 360 minus it, you get the other angle. And then from there on, both these angles repeat every 360 degrees. So the next time the curve is going like this, down like this, at, corresponding to this point, will be 360 degrees away from it. All right. So for the cosine curve, I personally don't like the cast diagrams. I like to use this method here, where I just simply, if it's cosine, calculator answer, 360 minus the calculator answer, and then add 360 to your answer, add 360 to this answer, it gives me something in the range. Add 360 to that answer, well, we're gone outside of the range, so we stop. Simple as that. Okay, and for the sine curve, because of the symmetry of the sine curve, it's the angle that the calculator gives you, then 180 minus the calculator answer, and then the same thing, add 360 to the answers. For the tan curve, it's even easier. It's just what the calculator gives you, and then that repeats every 180 degrees. You have that angle, and then 180 more than that angle, 180 more than that angle, 180 more than that angle, and if you want to go on the negative side, you do that angle minus 180 and so on. All right, so it's pretty simple, just if you understand that, to answer the questions in that particular method. So now what we can do is we can find what x is. So we're going to reject this answer. We're going to take these two answers. We have 333.435 minus 71.57. I think it was 565 actually. Okay, before when we got it, let's just make sure. Okay. Yeah, so I'll keep it as that for now. So it's the same degree of degree of accuracy for my calculation. All right, and the other angle would be 386.565 minus 71.565. Okay, so those will be our answers. So we have yeah, sorry, that's from something else. Let's go back. Yeah, 71.565. Just making sure that was the answer that we got before. Okay, good. So we have here 333.435 minus 71.565. That gives us 261.87. Okay, and here we're going to have this will be 386.565 minus 71.565 gives us 315 exactly. Okay, so answers, if not specified for degrees, angles and degrees should be one decimal place. So this is 261.9 degrees and this is 315 degrees. This looks like it's exact. So there we have the answers to this particular question, and that's the question finished. Okay, so I hope that was clear. All right, so we had to first of all, in part A, rewrite this in this form and then use this form to solve the equation given. So that completes this equation. I think maybe this would actually give us 262 in an exact form in the end, but I think this should be fine because they told us to round it anyway. But supposing we had used the exact value just to show what would have happened, we end up with, that would have been 360 plus this. Okay, yeah, it would have given us exact 675. Okay, and then we would have had 675. That's fine. Leave it like that. That's fine. Okay. So anyway, other questions from this paper can be found in the playlist that will appear in this section over here at the end of the video. Other questions from the topic of trig equations and identities you can find in the playlist that will appear in this section over here. Yeah, so this is from P3, trig identities and equations. If you would like to see the questions that I have from my P3 collection of Excel on trig identities and equations, there will be a lot of videos there that you could see that are very similar to this. You can find the playlist over here. You can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.